As you have seen in the previous videos, EMT and Cosmos are building an application for people with special needs in order to assist them in their routes across the city of Madrid using EMT bus lines. Cosmos also supports the creation of innovative flows that are able to identify smart events with automatic complex event rules boundaries creation based on the combination of historical data and machine learning methods. The purpose of this demo is to demonstrate how these two sources of information are linked together and cross-correlated in order to produce added value for the Person with Special Needs app, namely to identify events that may actually affect people with special needs during their travel and to alert the responsible caregivers. Initially, the caregiver logs in the EMT portal in order to design the route of the person with special needs. In order to do so, they select dates of the travel as well as the start and end points. Finally, they store the route, which is calculated along the intermediate checkpoints and the necessary trip segments. For this demonstration, we have already created one route, the route at test number 2, that passes also close to a measurement point of traffic for which we have modeled traffic events. Cosmos has created another flow that has the role of merging information coming from the EMT portal about a specific route, data input layer, with the Cosmos Smart Events consumption coming from the Cosmos services on the left. Data input coming from the EMT case can be seen in the logs screen at this point, just to get an idea of how the information is fed. The flow responsible for the event identification can be seen here in a separate Nodder tab, where the Cosmos CEP engine initially listened on Madrid city traffic sensor data. Then it triggers a suitable BAD event whenever the relevant condition is met. Finally, the visualization flow can be seen, which feeds into a freeboard panel, the Cosmos Traffic Management GUI, through which city of EMT officials or even citizens can monitor in real time the condition of the traffic. We have also created manual triggers for events coming from testing purposes. Configuration of the flow is done via an according node in order to include necessary users and level of information to which we want to register, as well as radios. Necessary information may include, for example, user tracking coordinates, route plan details, or checkpoints reached. The radius is the defined radius between the user and the event that we consider as affecting the user journey. If the distance of the user is less than this limit, then it is considered that the event affects the user and thus the caregiver should be notified. This is all calculated in the app logic part in the center of the flow. Once the correlation is identified, the data output layer is activated, which is responsible for pushing this information to the EMT Reactive Box portal in order to be displayed in the end user's front ends. Forwarded information includes user location, type of event, and text for notification, as well as details for the displayed icon. In order to emulate the trip, we use a suitable emulator developed that retrieves the route from the EMT portal and emulates the motion of the user and will eventually act as a front-end app for the caregiver. For this case, we must set the user and password and select the route, and we are about to start the simulation. In the Nodder console and output information, we can see how this information of user movement for the specific person with special needs is forwarded toward Cosmos and his GPS changing, but not used until a bad traffic event is detected. Let's start the simulation. The user has started moving. He's waiting at the bus stop for 230 seconds. Bus information is real-time data coming from the EMT platform, so there is an actual bus arriving at that bus stop in 230 seconds. If we enable the debug tab, we can see added events of user start. However, there is no event forwarded to the output since no bad event has occurred. Now we manually trigger a bad event for a specific point of measurement with these coordinates. Thus, we will be able to see in the next GPS change the notification towards the output. The GPS calculation will also appear in the logs. We must wait until the user boards on the bus and starts moving. The user has boarded the bus and the bad event has already been activated, so notifications reach the output tab. GPS calculation is very near the point of measurement, 0.3 kilometers, and we get the notifications that are also shown in the Reactive Box portal. Two alarm markers are with relation to start and end of route. The third one is the one produced by Cosmos as seen from the timestamp and user warning message, user near a congested traffic point. User keeps moving, and we can see from the logs screen that the distance between him and the measurement point increases, but still it is within the defined radius, so notifications keep getting produced with each GPS change.